Today we'll resume lesson 5.7, solving logarithmic and exponential equations, and we'll be solving them algebraically. In this lesson, we'll be looking at questions from your textbooks, exercises. Just a review, that exponential and log equations can be solved algebraically. We've completed a few examples in the previous lessons. And we'll be applying the laws of logarithm and also the definitions for logs. Let's look at the first. One of the questions to ask here to discuss the ideas: why is it necessary to verify the solution of a log equations? Now, remember the previous questions, some of the previous questions we've completed regarding logs. We need to verify to find where it's defined, because a log is only defined for positive real numbers. So in a solution of a log equation, there may be extraneous roots. So all solutions for logs must be verified. So you do not want a negative number for your solution. That will be classified as an extraneous root. So that is the reason why I need to verify, because a log is only defined for only positive real numbers. So we can say that a log is only defined or is defined, or let's just say, defined only for only, for only positive real numbers. So if you have a solution, there may be extraneous root, right? So in the solution of log equation, there may be extraneous roots. Or I should say roots. So all solutions must be verified. So remember, you only need, for log, it's only defined for positive real numbers. So that is the reason why you need to verify your solution, to eliminate any extraneous roots. Next one is the roots of a log equation always positive. So it looks like a contradiction here. A log is defined only for positive real numbers. The answer is no, right? And the reason is because you may have the root can be negative when it is substituted into the original equation, right? Because no, the root can be negative. It doesn't always have to be positive. But when it is substituted into the original equation, it cannot result in the log of a negative number. Even though you may have the root can be negative, but when you enter into the original equation, it will be positive. You cannot result in a negative number, in other words. We did a few examples. We'll go through a few other examples to demonstrate these two facts. Now let's go on to question 4 in your exercises here. Question 4 asks you to write each expression as a single log. And here we're going to use the product law or the quotient law or the power law. So we'll be using a combination of these three log laws or one. So let's look at the first one. Remember, you were writing as a single log. We want to have a single log. So the first one here, we can use the product law because we can use the product as a plus here. And the roots are the same. So use the product law. So product law. This will give us log 5. Now we will multiply these two. X plus 2 times x. So this should become 5 into x squared plus 2x. Okay. So the next here, clearly we can use the product law again. So let's do the product law. So log 3 to x minus 5 times x plus 3, which is log 3 x squared x times x squared plus, or b, plus 3x minus 5x minus 15. Simplify. We have x squared minus 3x minus 15. Two other examples. Let's look at C and move on to D. So question C, we have log x minus 7 plus log x plus 7. We're adding, so we'll use the product law. So we have log. Now this is log base 10. So we have x minus 7 times x plus 7. Gives me log x squared. The difference is square, so this is pretty straightforward. Line is really crooked here. Here we have log 6. Now it's a difference, so this will apply. First of all, we have the power law we'll use here, and then we'll use the quotient law. So we have to use the power law here. And then there's a negative between the log 2 log 6 log 6 and log 6 over here, we can be quotient. So let's apply the power law first and give us log 6 into 3x minus 2 minus now, this could be a log 6x2 over 2. Now we're going to apply the quotient law. Log 6, which gives me 3x minus 2 divided by x squared. So you're applying the product law in the first case here. The previous questions, A and B, we apply the product law. And the final one, we apply the power law and the quotient law. So we applied all three log laws. Okay, let's go back. This is also, we did a few examples of these. So also, if you go back to question 3 in your book, it's very similar questions. In this case, we apply the quotient law. And give us log 24 over 3, which end up in being log 8. Next one, you apply this would be a product law. So log 2 over 4. No, it's a product law. We multiply, not dividing. Log 2 multiplied by 4. Log 8. Now, that makes sense. Interesting, both answers are the same. Firstly, look at this here. We can have 2 log 4 minus. So the log is similar, except here we have 2 and this one have 1, but we just subtract here. This is more or less a trick question. So 2 minus is a 1 here. 2 minus 1 will give us log 4, or 1 log 4. And next we have, first thing we'd apply the power law. Get rid of both of these here. This is the power law. So log 2 to the power 3 plus log 3 squared. Then we'd apply the product law. So we have log to the power 3 multiplied by 2 to the power 3 is 8, multiplied by 3 to the power 2 is 9. That gives me log 72. Now here we are asked to solve for this exponential equation, give the solution to the nearest hundredths. In this case, we will also be applying the change of base formula. So we'll convert, first step, we'll convert this into a log. The next step, solve for x and change of base. So step 1, now because we have 60, change it into log, both sides, log 3. So this is our base here, we want to change it. By doing that, we will be, remember this is log b to the n is equal to n. By doing that, I will then make, this will be applied to this definition here. So we have log, so we can write here, write both sides, log 4. So we have log, also log 3, not log 4. So log 3 of 60, log 3 of 3 x plus 1. All of this now becomes x plus 1. Because we're applying this rule here. So we have log 3 to the power of 60 is equal to x plus 1. Now, simplify by, this would be not correct. Okay. Now I'll move this over here. So we have x plus 1 is equal to log 3. Now I solve for x here. So x is equal to log 360 minus 1. So x, now we have a change of base. Log 60 log 3 minus 1. So log 60 over 3 is what we need our calculator. So log 60 divided by log 3, 3.72, or approximately 3.73. So 3.73 minus 1. So x is approximately 2.73. Seven B, we'll go through that right now. But the first one here, we want to take the base, take the log base 5. So take log base 5 for both sides. So we'll have log 5x minus 3 equals log 200. This side now becomes x minus 3 equals, now here we're going to apply the change of base log. But first we can simplify our x, so x is equal to log 200 plus 3. So log 200, change of base here. So log 200, let's see what that looks like here. So log 200 divided by log 5. So it's 3.29 approximately plus 3 equals 6.29 approximately. So x equals 6.29. Question 9, there are two parts to question 9. And here you're asked to solve and find the value of x and verify the solution. Remember, you cannot have a negative number for your log as your solution. So let's look at this question here, the first one. Step 1, we want to find out where it is defined. Okay. So step 1, consider values of x for which each log is defined. That's our first step. We want to make sure where it's defined. So the first one here, for x is defined, that's greater than 0, the log 2 of x. So x has to be greater than 0 here. And x must be also greater than -6. So x has to be greater than 0. So we can say, so x has to be greater than 0. So we have established where the values of x for each of the log is defined. Okay. The next step is to use the laws of log in this case. Here, because it's log 2, we can use our product law to simplify this. We have 4 now is equal to log 2 x times x plus 3. x plus 6. Okay, let's rewrite this properly. So it's x multiplied by x plus 6. So 4 is equal to log 2 gives me x squared plus 6. Now write both sides. Now change this into an exponential. So we're going to change this into an exponential, write as an exponential. So it becomes 2 to the power of 4 is equal to x squared plus 6. Okay, so 2 to the power of 4 is equal to x squared plus 6. So we write this as an exponential. So this is what we have. So we write that as an exponential. So 2 to the power of 4. Now we will solve for x. Solve. So 2 to the power 4 is 16. So we have 16 is equal to x squared plus 6. So 0 is equal to x squared plus 6. This should be x there. Minus 16. So factor. So this gives us what? X minus 2 here. X would be 8. Right, plus 8. So roots are x equals 2 and x equals negative 8. So this is extraneous. So a solution x equals 2. So to verify, so let x be equal to 2. So on the right side, if you look at the right side, be log 2x plus log 2x plus 6. We will substitute 2 for x. So we have here log on the right side. 2 plus log 2. It will give us what? 2 plus 6, which is log 2 to the 2 plus log 2 to the 2 thirds. So it would be 2, so it'll be 1. It's going to be 1 here. So it'll be 1 plus 3. So 4. So 4 is equal to the left side. So we have 4 is equal to the left side. So it's a very fine solution. So let's look at the last question. We'll repeat the same process as before. Here we have log 6x plus log x minus 16 equals 2. For a step, consider the values. So consider the values x for which each log is defined. So here x is greater than 0, x is greater than 16. So x has to be greater than 16. So we use a product law. So we, step 1, use product law. So this becomes log 6 to x into x minus 16 equals 2. So we have log 6 to the x squared minus 16x equals 2. Now we got to write this as an exponential. So 6 to the power 2 is equal to x squared minus 16. So 0 is equal to x squared minus 16x minus 36. Now we factor. So if it's x on my left side, it's be x and x, and will that be 18 and 2? Oh, the factors of 16. Oh yeah, okay. So 18 and 2 are the factors here, so we can have minus 18 here, plus 2 is the x squared. Yes. So we can have x is equal to 18, or x is equal to negative 2. So negative 2 is extraneous. So our solution is x equal 18. So verify, let's verify our solution. So we say that x is equal to 18. So we look at our left side in this case. So left side, it's log 6x plus log x minus 16. This gives us log 6 to the 18 plus log 18 minus 16. Simplify this, we have log 6 to the 18 plus use a product law here, we can combine it, we can log. So 18 times 2, which is log 6 to 36. Now, we can now change this to log 6 to the 6 squared, which is 2. Which is the same as the right side. So the right side is equal to 2 also. So our solution is verified. So just a review here. Whenever we are solving for a log equation, first step is to consider the value of x for which each log is defined. Once we have that, we can change the exponential form and solve for x. We find our extraneous root if it's negative, or if it's less than what's defined, then that's your extraneous root. And we verify by substituting our solution into one of the sides. In this case, we use a log, and find out if it's equal to the other side. Our next lesson, we are going to look at verifying each log, solving exponential equation algebraically. So we'll continue a few more complex examples, solving algebraically log and exponential function.